Hello, I'm Hamada from Tokyo Institute of Technology. Today, I'd like to talk about individual and longitudinal trend analysis of Stairway Gait using a Handrail-Shaped force sensor. Here's the outline of my presentation. After I talk about the background of this research, I'll talk about system configuration, verification of fundamental functions, long-term monitoring experiment, and conclusion. First, I'd like to give you some background about my research. The population of elderly people is increasing year by year. This figure shows changes in physical functions of the elderly people. As they get older, they become frail and ultimately require long-term care. However, proper intervention during frailty can improve their health. Therefore, early detection of frailty is important for delaying long-term care and prolonging life expectancy. In Japan, frailty has been assessed using a simple questionnaire, but this assessment has the problem. That is, it depends on the subjectivity of the evaluator. Therefore, we need to evaluate frailty objectively. There is an evaluation question related to exercise, the checklist, which is, do you normally climb stairs without using handrails or wall for support? Since the stair handrail is such an important item to evaluate frailty, we decided to use to measure physical function. With this background, our research team developed a handrail sensor. Considering long-term monitoring in the house, this sensor has many advantages. First, it can avoid privacy problem because it doesn't use any images. Second, it can monitor elderly in an ambient way. Therefore, elderly doesn't need to use sensor intentionally. The purpose of this research is to understand the long-term characteristics of the elderly's ascent and descent using a handrail-type force sensor system. Next, I will describe the system configuration of handrail sensor. A handrail sensor installed in the user's house measures the load on the handrail. Then, send the data to the cloud service and save them. The analysis system uses the data on the cloud service to analyze the physical functions of the users. The analysis system performs speed estimation, multi-person data discrimination, and long-term trend analysis. Next, I will describe the Handrail-Shaped sensor. The sensor consists of a wooden railing and metal fittings. In addition, the fitting is equipped with a biaxial strain gauges to obtain the load on the handrail. This slide shows that how the handrail sensor is acquiring the data. Next, I'll explain walking speed estimation function. Previous studies pointed out a relationship between walking speed and frailty. Therefore, we focused on the speed of stair ascent and descent. The grasping position is calculated based on the theory for a beam supported at both ends. The change in grasping position divided by the elapsed time is defined as the ascent or descent speed. Next, I'll explain multi-person data identification function. This feature uses handrail load data to identify who went up or down the stairs. In this study, we applied LSTM network to identify the differences in individual characteristics. To create the training data, we first extracted the load data on the handrails. Then, I visually checked the camera images to see who was using the stairs and leveled that load data. Then, We trained the level data on the LLCM and created a classifier to identify the subject. To verify the speed estimation function, we use a Handrail sensor and a Kinect, which is the RGB camera. We took data from the Handrail sensor and Azure Kinect at the same time and analyzed the speed from each data. And we confirmed the consistency of the two types of speed. We used velocity analysis with Azure Kinect calculates ascending or descending velocity VA based on changes in waist coordinates and elapsed time. The change in waist position divided by the elapsed time is defined as the ascending or descending speed. Here is the experimental condition. In the verification experiment, the subject ascended and descended a stair 50 times in a laboratory environment. Here is the result. The vertical axis shows the speed analyzed from Azure Kinect, and the horizontal axis shows the speed analyzed from the Handrail sensor. The correlation coefficient between the speeds was high as 0.77, validating the effectiveness of the speed analysis function. Next, to verify the multi-person data discrimination function and conduct long-term data analysis, we install a Handrail sensor on the stairs of the house where a 73-year-old woman and a 77-year-old man live. In addition, we install an Azure Kinect to simultaneously acquire data to confirm the subjects were ascending or descending the stairs. The data were recorded for 6 months. We'll explain the verification results of the multi-person data discrimination function. We used data for 80 ascents and descents for subject 1 and 2. In the verification, tenfold cross validation was performed. Here is the confusion matrix for the result. The accuracy for ascent was 88.1% and that for descent was 86.8%. This indicates that this is possible to identify data for an individual user using Handrail sensor values. Next, I will explain the results of long-term data analysis. We analyzed all the trend analysis of maximum loads applied to handrails during stair climbing. The left figure shows the load for subject 1 and the right shows the subject 2. The median handrail load for subject 1 decreased over time, suggesting that this subject's dependence on handrails decreased. Finally, I'd like to conclude my talk about the short summary of our study. The objective of this study is to develop a Handrail-shaped force sensor for monitoring the physical functions of elderly people. To verify the effectiveness of the speed estimation function, we conducted an experiment in a laboratory. The correlation coefficient between the speeds was high. Also, to verify the multi-person data identification function, we acquired ascending and descending data of 2 elderly people in a real environment. The accuracy of individual user recognition was 88.1% for ascent and 86.8% for descent. We also performed a trend analysis using 6-month long-term monitoring of 2 elderly people in a real home environment. This experiment showed that it is possible to evaluate the subject's dependency on the handrail. These results suggest that the usefulness of the handrail sensor and its system. Thank you.